There is no such thing as time. This may sound like a strange claim for a video about time, but it's not quite as crazy as it sounds. So stay with me here. We're going to explore why everything you know about time might be wrong, including what time travel actually means, how we really experience time, and how science has been hiding something from us. Let's start with some basics. We generally think of time as a tick-tock on a clock. Something happens at this time, then something else happens at that time, and we measure these moments by counting the rotations of the Earth on its axis and its orbit around the Sun. But if you think about it, that's just measuring chunks of energy hitting a detector. Sunlight or starlight. In other words, it's measuring light. So, can we see time? No. Can we hear time? No. Can we smell, taste, or touch time? No. If time is nothing more than our detection of energy, which is itself just a measurement, then there can be no time without an observer. The realization that our perception of time depends on our ability to detect energy shouldn't be all that surprising. After all, we see things only when light hits them, and we hear sounds only when pressure waves hit our ears. What might be surprising, however, is that this applies to more than just our everyday experiences. Our very conception of time and how we use it to understand the universe is also dependent on our ability to detect energy in various forms. Take gravity, for example. According to Einstein's theory of general relativity, which is one of the two pillars of modern physics, gravity is the result of changes in energy due to the curvature of space-time caused by mass. This curvature affects how objects move. So, without being able to detect changes in the curvature of spacetime, we wouldn't even know what gravity is or how to calculate it. The same goes for electromagnetism. It, too, is a manifestation of changes in energy, specifically changes in electric and magnetic fields over time. Again, without our ability to detect these changes, we wouldn't know electromagnetism existed. But wait a minute, isn't that exactly what we do measure? We measure changes in energy. That is, until we look at quantum mechanics, which is the other pillar of modern physics. Here things get weird because according to quantum mechanics, energy doesn't exist without an observer. It's not that energy goes away when we're not looking at it. It's that energy can be in multiple states at once, but once we observe it, we force it into a single state. Or, as Richard Feynman put it, energy is not a real thing at all. Energy is just a convenient word we use to describe what happens when things interact. Now, if this sounds counterintuitive, it's because it is. But it's also been confirmed over and over again through experiments, and it raises an interesting question. If energy is nothing more than our detection of interactions, and those interactions are always happening whether we're observing them or not, then what are we really observing? Are we truly experiencing time, or are we experiencing changes in energy? To answer that question, let's take a look at what happens when we try to measure time. When we want to measure time, we first need to detect a change in energy. And to do that, we need a physical system that responds to that change in energy. These systems are called clocks. There are many different types of clocks, but they all share one thing in common. They respond to some interaction that we can detect, such as the change in pressure when air molecules collide with the diaphragm of a microphone, or the change in capacitance when our body blocks radio waves. These changes can then be translated into a reading on a display, which we interpret as a time. But this brings up another issue. To interpret a sequence of numbers on a display as the time, we need to have a frame of reference. For example, we could say that the time is to p.m. on January, but that doesn't mean anything unless we also specify that we re on Earth in the year 2024. In other words, time is relative. It depends on our location and our frame of reference. This is a key part of Einstein's theory of special relativity. He showed that time is not absolute, but rather depends on the observer's frame of reference. So, if time is relative and our perception of time depends on our ability to detect changes in energy, and changes in energy only appear to happen over time when we observe them, then Does that mean that time doesn't really exist? Well, yes and no. Yes, in the sense that time is not an absolute quantity that exists independently of observers. No, in the sense that time is still real. It's just that the way we usually think about time is wrong. Here's what I mean. Let's imagine that we have two observers, Alice and Bob. Alice is standing still on the Earth while Bob is moving in a spaceship at a constant velocity. Both observers have a clock with them, and both clocks are synchronized to show the same time. Now, according to special relativity, Alice and Bob will measure the passage of time differently. This is because the faster you move, the slower time passes relative to someone who is not moving. So as Bob moves away from Earth in his spaceship, time slows down for him relative to Alice. This means that at some time, when Bob returns to Earth, he will be younger than Alice. This may seem counterintuitive, but it's been confirmed over and over again through experiments. And it makes sense if you think about it. If you're moving really fast, you're constantly changing direction, and that requires a force. Forces, however, require energy, so by conservation of energy, you can't be moving really fast forever. Eventually you'll run out of energy and slow down. This means that time can't pass for you at a constant rate forever. It will eventually stop. This is known as the ultimate fate of the universe. As the universe continues to expand, everything will eventually move away from each other, and this will cause time to stop. So while we may think of time as a tick-tock on a clock, that's really just a human construct based on our ability to detect changes in energy. The truth is that time is relative and observer-dependent, and one day our understanding of it may change even more. Now that you know how time works, you may be wondering if there's any way we could use this knowledge to our advantage. Enter time travel. According to Einstein's theory of general relativity, it is possible to travel back in time. However, it's not possible to travel forward in time. This is because traveling forward in time would require you to move faster than the speed of light, which is impossible. But traveling back in time is possible under certain circumstances. For example, if you were to move really fast, you would age slower than someone who was not moving. This means that if you return to Earth after traveling at near light speed, you would be younger than the people who stayed behind. So, in a sense, you would have traveled back in time. The catch is that you would only be able to travel back in time by a very small amount, and you'd have to move incredibly fast to do it. This is why time travel is often depicted in science fiction as requiring a spaceship that can move at near light speed. But what about traveling further back in time? For example, what if you wanted to travel back to the beginning of the universe? Unfortunately, that's not possible according to our current understanding of physics. This is because the beginning of the universe was a singularity. A singularity is a point of infinite density and zero volume, and it's technically impossible for anything to travel to or from such a place. However, that doesn't mean that we can't learn from the past. By studying ancient artifacts and fossils, we can learn about the history of our planet and the evolution of life. We can also study distant galaxies and stars, and by looking back in time, we can see how the universe was in the past. In a sense, we can travel back in time by studying the universe. And while we may never be able to travel back in time physically, we can always learn from the past. So next time you're feeling like you're stuck in a rut, remember that time is relative. All you need to do is change your perspective and you'll be on your way to a whole new adventure. Thanks for watching.